Let us now look at the position of a point with respect to a circle. In fact, before looking at this concept, let us look at the meaning of these two terms, S1 equal to 0 and S11 equal to 0. Right, so I'm introducing two new terms to you. Let us see what they mean. So, let this be your curves equation, right? X square plus y square plus 2gx plus 2y plus c equal to 0. You know this is the general equation of a circle, right? In fact, any curve, even if I pick up some other, like the general second degree polynomial, x square plus 2hxy, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Even this I can call as S, right? S just means I'm taking the equation of a curve, right? That is what your S means. Let this point be your x1, y1, right? P. What do I mean by S1 equal to 0? S1 equal to 0 means what I will do is, this is x square, right? So I will split it into x plus y into y plus this is g into 2x, right? So 2gx means g into 2x. So g into x plus x is what I will do. F into y plus y is what I will do, right? Plus c is equal to 0. So this x, this y, this x and this y, so they are occurring twice, right? What I will do is, one of them I will change to x1. That means this point x1, y1, I will put it in the curve in this manner that one of these x changes to x1, one of the y changes to y1, one of the x here changes to x1, one of the y here changes to y1, plus c is equal to 0, right? So this term is called S1 equal to 0. If I say S11 equal to 0, then that means in both the xy's, wherever your x and y is there, everywhere I will put x1, right? So that means I will do x1 into x1. Previously I did x into x1, now I will do x1 into x1 plus y1 into y1 plus g into x1 plus x1. So this x also I made x1 now. Plus y into y1 plus y1. So this y also I have made y1 now. Plus c is y1 plus c is equal to 0. So S11 is basically putting the point in the curve. So wherever you have xy, you're just putting x1, y1, x1, y1. So in fact, you will get this x1 square plus y1 square plus 2gx1 plus 2f y1 plus c is equal to 0. This is what you mean by S11 and this is what you mean by S1. So notice the difference. In S1, what you do is, for one, in place of one of your xy's, wherever you have two x's together, you just put one of the x's as x1. Wherever you have two y's together, you just put one of the y's as y1. So if you notice this difference, now you know the meaning of S1 equal to 0 and S2 equal to 0. So you know the meaning of these two terms now, these two expressions. So let's see where these expressions are useful. So for finding the position of a point with respect to a circle, which is also called as power of a point, what we do is, we simply evaluate what is S11, the value of S11, right? What do you mean by S11? You know it. You'll take this point, you'll put it in the equation of the circle, that is this, right? So basically, you will evaluate x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So if this S11, which is this, right? So obviously when you put it, you'll get a number. If that number is greater than 0, then the point is outside the circle. If that number is equal to 0, then that point is on the circle. If that number is less than 0, then the point is inside the circle. So this was the result. So obviously, if you look at this point, what will be the value of S11 for this point? I don't know what it will be, but for sure it will be greater than 0 because the point is outside the circle, right? If I take a point here, if I call this as P dash, what will be S11 for this? What will be S11 for this? So I'll put the coordinates of this x1, x2, y2 maybe. So what will be the x1? So I'll put the coordinates in the equation of the circle and I'll get it equal to 0. Why? Because it's on the circle, right? So S11 for this point is equal to 0. And if I take a point inside, P double dash, it might have coordinates x3, y3. Now, remember, for this also I will call it S11. I don't call it S33, right? Just because I'm, telling the coordinates as x3, y3, I don't call it S33. S11 means this method. S11 means putting the point in the circle. That is S11. Whether that point is x1, y1, or x2 y2 or x3 y3, it doesn't matter. It all means the same thing. You will take the point, you'll put it in the equation. That is S11. And S1 means this, right? So we are not using S1 right now. We'll be using it when it comes to tangents and all. But right now we are using S11. So what will be S11 for this point P double dash? It will surely be greater than 0. Why? Because this point is inside the boundary of the circle. So these are the conditions that you need to remember. So you can find the position of a point with respect to a circle if you remember this. Let us now look at the minimum and the maximum distance of a point from a circle. Let us now look at the maximum and minimum distance of a point from a circle. So you have this point here. So what are the maximum and minimum distances? I have actually put the formulas here, but what do they mean? So this yellow arrow's length, this is the minimum distance. Like, so when you start traveling from the point P towards the center, so if you start traveling from P towards the center, you will first hit the circle at this point, right? So this is the shortest distance. Coming to so this is the minimum distance, right? Minimum distance. Coming to the maximum distance. So if you keep traveling from this point P towards the center, you reach the center, but you still keep traveling, you will hit the circle at this point, right? So this entire length is the max distance. So as you can see, minimum distance is, if I find the distance between these 2 points, CP, and if I subtract the radius from that, I'll be getting this pink arrow. This yellow arrow, right? So minimum distance is CP minus R. But I put a modulus for a reason, because if your point is like, this is your C, this is your P. If your point is inside the circle, then this is your minimum distance. In that case, if you do CP minus R, your CP is this big and your R is this big. So in fact, you need to do R minus CP. So CP minus R will give you maybe minus 5, and R minus CP will give you plus 5, but the distance should be positive, right? That's why we have put this mod sign, so that the formula is valid even for points inside the circle. So in that case, this will be the minimum distance and this will be the maximum distance, right? If you keep traveling towards the center, you will hit the circle on this side. So this is what it was. Coming to maximum distance formula. So as you can see, this is the maximum distance, like from this point to this P, right? Now this is comprising of two lengths. One is your CP and one is your R, right? So if you add CP and if you add CP to the radius, you will get the maximum distance. CP is basically, it's distance between 2 points. You have your first point C, you have the second point P. Use the 2-point formula for distance between the 2 points and get CP. So CP plus R is maximum distance and CP minus R is the minimum distance. This is valid for both points inside, outside, and even on the circle. The fact is, on the circle, your minimum distance will be 0 because it will be exactly on the circle. So CP will be R, right? So it will be 0, and your maximum distance will be this diameter's length, right? CP will be R, so 2R will be the maximum distance. So this formula is valid for all the 3 cases, whether your point is outside, inside, or on the circle. But just remember this formula and remember the mod in case of minimum distance. So with this topic done, let's move on to the next subtopic.